Okay, class, so now for our very last lesson of the space unit, we're going to talk about the formation of our solar system and the universe as a whole. So it says here, formation of the solar system, the solar nebula theory. So guys, this solar nebula theory is the most widely accepted explanation as to how our solar system formed. So in general, our solar system formed approximately 4.5 to 6 billion years ago. Okay, and keep in mind it's called the solar nebula theory. Okay, and this is the idea that 6 billion years ago, a whole big massive cloud of dust and gas known as a solar nebula. And remember, when we did the stars lesson, the birth of a star began with a nebula. Okay, so the idea that this big massive cloud of dust and gas known as a solar nebula was created. And over time, eventually, gravity caused the matter and material, that gas and dust, to collapse in on itself, and this formed the sun at the center. The remaining material began to clump together. Okay, and that remaining material that began to clump together began to contract outward. Okay, so now we have the sun at the center of this solar system and all of this extra remaining material starting to drift away. Okay, so that brings us to our terrestrial planets. So these are our inner planets, guys, made up of Mercury, Venus, Earth, and Mars. Remember, these guys are composed mainly of rock and metals, okay, specifically iron, okay, little hydrogen and helium. Okay, we know that our outer planets are more made up of hydrogen and helium. Okay, so our terrestrial inner planets are made up of rock, Mercury, Venus, Earth, and Mars. And so what happened was our young sun produced solar wind to push away hydrogen and helium to the outer regions, but this left chunks of heavy matter behind. Okay, the chunks eventually started orbiting the sun and started to collide, which started to form our terrestrial planets. So it's this idea that solar wind started to push away the lighter elements, the lighter gases, which are hydrogen and helium, push them to the outer regions, but was left over was these metals and this heavy rocky matter. And this matter starts to collide, all these small chunks starts to collide, and eventually forms our 4 inner planets that then start orbiting the sun due to the sun, our stars, immense gravitational pull. Okay, then we have our gas giants formation. So our gas giants are our outer planets, Jupiter, Saturn, Uranus, and Neptune. Attracted by the force of gravity, the clumps became planets. So again, these clumps of matter or materials started to come together, and again, due to the sun's gravitational force, starts to orbit the sun. So the gas giants are made mainly of the hydrogen and helium because, again, the sun's solar winds pushed those lighter gases out further. Okay, so that's why our outer planets, our gas giants, are mainly made up of those elements. Planets formed similar to the sun, so clouds of gases contracting due to gravity. Okay, and here are some videos for you guys, formation of the planets, and a little bit more about the gas planets. So the solar nebula theory, again, the most widely accepted as to how our solar system formed. Now we're going to talk about the origin of the universe. Okay, so it says here, time zero. 10 to 15 billion years ago, when all the matter of the universe was packed into one small and very dense mass. Eventually, an event occurred when the universe emerged out of this dense mass. So it's interesting to think that our solar system formed about 4.5 to 6 billion years ago, but the universe formed about 10 to 15 billion years ago. Okay, so this brings us to the Big Bang Theory. this is the theory how astronomers explain the way the universe began. So it says here, cosmic explosion that hurled matter in all directions, used to help explain our observation that the universe is expanding. So the Big Bang Theory is the idea that all matter was compacted into a small ball that had infinite density and intense heat, and it began at a single point, and then it expanded and stretched to grow as large as our universe is now today, right? And it's still expanding. Okay, so this is just a diagram here to show the theory of the Big Bang. So on the left here we have Big Bang, okay, and then as time goes on, we'll see different things happening in space. So stars are forming, first stars appear. That was 100 million years after the Big Bang. Eventually, first galaxies appear 1 billion years after the Big Bang. Okay, evolution of galaxies continue, and then eventually our solar system forms 9 billion years later. And then here we are today, 13.8 billion years after the Big Bang. Okay, and here's a video that discusses the origins of the universe based off of how astronomers explain how the universe began. So this leads us to, is our universe expanding? So when we learned about stars, we did hear the term redshift. Okay, so Hubble saw a pattern that shows galaxies are shifting in the red spectrum, suggesting that they are moving away. Okay, so when we looked at stars, we looked at emission spectrums, and we saw examples where sometimes those absorption lines have shifted to the red end of the spectrum. And when that happens, that tells that those stars or those celestial objects are actually moving away. And if those objects are moving away, this is evidence that the universe is still expanding. Okay, there was also blue shift that we talked about, which is the opposite. Those absorption lines are shifted to the blue end of the spectrum, which means that those objects are moving towards Earth. But because red shift is a real thing, right, this is evidence that because these objects, these celestial objects, are moving away from Earth, that shows that the universe is expanding. So the future. Expansion continues. The repulsive force of dark energy, okay, force of energy working against the force of gravity, may eventually overcome the gravitational pull of matter. So it's this idea that expansion of the universe is going to continue to happen, okay, and like I said before, we see that through redshift, and there's the idea that expansion continues because of this dark energy force. So gravity, or the force of gravity, is pulling everything in. So when we talk about stars and the gravitational pull, it's like collapsing in on itself because the gravitational pull inward is so strong. But if the universe continues to expand, then there's this idea that there's this dark energy that's doing the opposite or working against the force of gravity. Okay, and if that dark energy eventually overcomes that gravitational pull, that's what's causing this expansion. So over billions of years, dark energy will pull apart galaxies, leaving behind cold, empty space. So the distance between celestial objects is going to continue to increase because of this dark energy, expanding the universe even more, leaving more space between galaxies, pulling them apart. Okay, and here are some videos on redshift, guys, and the explanation of that.